So today's presentation, we'll be talking about an introduction to quality. And quality is a huge topic that pervades every aspect of both design and production. So this is going to be just an intro, and then we'll cover it again in I think the 7th presentation, where we talk a little bit more about regulatory requirements and certifications, which oftentimes go hand in hand with your quality plan and testing. It's essential for medical devices and any regulated industry, but it's just a good idea in general. So, for those of you who don't know me, my name is Matt Berlinich. I manage InnovationWorks manufacturing programs, and I'm part of the hardware team along with Jesse Mazzoni, who manages our Alpha Lab Gear program, and Mike Formica, who is the managing director of all of our hardware initiatives and investments. If you can, please turn your camera on, and I don't know if you can change your name with Google Meets, but if you want to connect with other people in the group, feel free to drop your name and contact info into the chat. That way people can know who you are, what you're working on, if you can help or collaborate with one another. This program was originally developed by NextCore, our partners in Rochester, and we are piloting the version 2 of the program right now. It was sponsored. NextCore is an MEP, a manufacturing extension partner, which is part of the NIST network of MEPs. They are economic development organizations similar to InnovationWorks, but their focus is to support manufacturing in the manufacturing industry in the US. And so the NIST MEP network sponsored this programming, which is how we are able to deliver it to you for free. NYSTAR also sponsored this, which NYSTAR is the New York's Department of Science, Technology, and Innovation, which also sponsors NextCore, and so sponsored this program. We have a bunch of program partners who have all contributed to this curriculum, including the Rochester Institute of Technology, Fuse Hub, Catalyst Connection, which is our local manufacturing extension partner in southwestern Pennsylvania, and InnovationWorks, who I represent. Today is the 4th presentation in this series, where we're going to do an intro to quality. In the first presentation, we did PRDs, product requirements documents and specifications, as well as general overview of product development, bill of materials and bill of process in session 2, cost modeling and risk management in session 3. And then next week, we'll be talking, well, not next week, in 2 weeks, we'll talk about design for manufacture, assembly, and then optimizing your design for any other variable that you would that is critical for your customer or market. Today, we'll talk in detail more about quality plans, quality test plans, and how process variation, depending on your manufacturing method, sort of influences those. We'll also do an overview of the full MRL assessment, which is a requirement for any of you guys who did a grant and or those who want to do potentially be eligible for any additional funding that we have available at the end of the year. The homework for today will be to draft a quality test plan, either for your prototype or whatever stage your prototype is at, as well as schedule future quality plan reviews so that you can make sure that you're not slipping in your overall continuous improvement process, a la Pierce. So let's talk about general housekeeping updates. So between last week and this week, I was finally able to get everything listed and up on the Scalable Innovation website, which is listed up here on the right. So we have all the past week's recordings there, and as we go through this the rest of the sessions, I will post the recordings once I receive them. And there's also the registration links to each website. From now on, the meeting link will be the same as this one, and it will also be every Wednesday at 1 p.m. We're just going to skip a week next week, and then the week after next for Thanksgiving. So that way you can sort of earmark your own calendars just to make sure. I also put the curriculum outline hyperlinked in here too, so that you can see the sort of the links to all of the documents directly, as well as the Google Drive folder overall. I push out updates about the program through MailChimp. So make sure every email about this program will start with the subject MFG Bootcamp. Check your spam and promotion folders, because it comes out through MailChimp and oftentimes gets caught up in the different filters. If you're not receiving those emails or they're not going to everybody in your team that you want to get them, have them sign up here. And then remember that for those of you who didn't receive the next core funding, we do have scalable grants available still, and you can find them on the Scalable website as well. And we will potentially have additional funding available at the end of the year. So general quick overview of the project approval process. Everybody that wants to participate will need to complete the full MRL assessment, which we'll go over in a little bit more detail later in this presentation. You'll then complete a project roadmap, which is in the session 8 folder right now. The template can also be found on the overview. Recommend you start getting quotes as quickly as possible. Any project that's over $10,000 will have to have multiple competitive quotes because it is federal dollars, and so they have to prove that you're not showing favoritism. Put some time on my calendar after you complete the MRL assessment and the roadmap so that we can sort of go over things. And then at that point, we'll introduce you to RIT to do their official MRL assessment. And once the roadmap template is complete, I'll introduce you to Catalyst Connection, who is our local MEP, who handles the contract side of things and the contract administration. So some general requirements to give you a heads up that will have to be in place before you can get the contract officially drafted and signed. You'll need to enroll in Catalyst's onboarding process, which basically just makes sure that you have a W-9 on record with them so that they can pay you. A DUNS number, which is now no longer a thing. It's called a unique identifier number, still administered by Dun & Bradstreet. And your business will have to be located in one of these following counties to be eligible for the next core funding. And then you'll have to have a NAICS code, which is free to sign up for, that coincides with manufacturing or engineering services. I have a little bit more of a list on that. And then as a result, if you do claim any funding, you'll have to fill out an annual impact survey from both us and Catalyst Connection for 3 years after the project. This is sort of standard fare for any economic development organization, just so that we can prove that the tax dollars that we're giving away are actually having an impact in stimulating the economy because your business is growing. So DUNS number, it's a unique 9-digit identifier number. Usually takes about a week. If you go to dnb.com, you'll find how to register for that. It's also a requirement for a lot of other federal systems if you ever want to do federal contracting. So highly recommend you get it. It's also used to do business credit. So if you ever want your business itself to have its own sort of credit score in the United States, you'll need a DUNS number. Better just get one ASAP. NAICS codes are industry identifiers. They're used by the Department of Labor to do statistics on sort of what do job numbers and job growth and economic growth look like in specific industries. They don't always keep up with the times that well, but Catalyst can help you sort of pick the appropriate one. Here are some common ones that are associated with manufacturing that don't start with 31, 32, or 33. And they're for sort of research and development stuff, metal services, engineering services, testing services, packaging, things like that, that just so happen to have different classifiers, but are still essentially manufacturing in the eyes of MEP. So, recap of what homework we've sort of assigned. I know that it just sort of there's a lot of documents and they're all interconnected and it can be a lot to sort of sort through. So brief overview. In session 1, we talked about requirements and specifications. All of that should be documented sort of at the top level for your product as a whole in a PRD. There are additional specifications which you'll need sort of for each component, especially any that you custom manufacture. And that will be sort of documented and linked on your bill of materials, your BOM. And then your bill of process is your sort of assembly instructions. So we said to at least start an initial bill of process, and depending on where your product is at its current stage of development and who you're looking to work for or work with to produce it, or if you're producing it in-house, there are different bills of process for different objectives, whether it's optimization or contracting or quality management, things like that. Session 3, we talked about cost and risk management, and we sort of walk through how you can use a cash flow forecast to make sure that you have enough cash and that you're choosing the right things and the right scale of NRE to invest in to make sure that you don't run out of cash. Your risk tracking document is a general document that you can use to identify risks to your business or your design that need to be addressed either now or in the future and what their level of criticality is. There's templates for all of that. There's not a cash flow template yet, but if you have a good one that you like, let me know. I'd be happy to add it to the folder for everybody to see. And then, so the PRD, the BOM, and the BOP are sort of your fundamental documents, and they are going to be continuously evolving. So in session 3, we talked about, after going through all of this cost and risk management stuff, keep making progress on your BOM and your BOP to identify and track all of the risks that you've also sort of identified, and your cost assumptions, which are probably going to be continuously changing as you sort of vet suppliers or move from COTS parts or commercial off-the-shelf parts to custom parts. The PRD is going to be real essential to this program, or to this particular topic of quality. So if you haven't filled one out yet, I highly recommend you at least take a stab at it. It's okay to have TBD specs. It's okay that it will evolve over time, but you sort of need a place to start in order to track what sort of quality objectives you're trying to meet and why, because they track to certain customer requirements. So now into the quality portion of this presentation. What does quality mean in this world in the sense of manufacturing? I like this sort of 3-part definition. It's that it meets your customer's expectations and that it will continue to meet those expectations under all expected operating conditions for the lifetime of the product. So that requires you to sort of define right off the bat in your requirements document, what are the conditions that this is going to operate on and for how long, as well as what are the things that your customer is expecting when they give you money in exchange for this product. So those are the 3 sort of most critical things that you need to do in order to get started in defining quality. But it's, if you've ever read Zen and the Art of Motorcycle Maintenance, it's pretty funny. I did not expect it, but the definition of quality is actually what drove the main character insane. He wrote a whole philosophical treatise on it. So check that book out if you're interested. But it does impact many, many aspects of the product, not just on the design and the production side, but also your customers. It impacts your sort of your reputation, both with your customers, but also against your peers. And that's something that we'll talk more about later in the certification side of things, is that there are industry standards which are published, and oftentimes, especially in specific industries, any public health and safety industry, there are standards which everybody meets. On the consumer side, there's not so much like a commonly accepted standard, but this is critical to establishing your quality program, is to sort of understand what the landscape looks like and see if there are certain standards that you'll want to meet. But a great place to start is just with your customers' requirements and what their expectations are. Does it meet them or does it exceed their expectations? And then at the sort of engineering tactical level, it really just comes down to, is your product free from defects so that it operates, but also significant variation so that, a la Anna Thornton's book, from 1 to 1 million, the millionth unit that you produce still functions the same and looks the same as the first unit, assuming that you didn't make any version changes there. So benefits of good quality, there's a whole bunch: reduce waste, lower costs, increase your customer loyalty, establish a reputation both amongst your peers and your competitors so that you can increase your market share. give you the ability to command premium price points, which is critical, especially in low margin industries. And then ultimately, where most people's head go, especially on the certification and regulatory side, is lowering your liability. We'll talk more about that again in week 7 as to like differences between regulation, enforcement, and just general liability. But what is the cost of a bad quality program or management? This is a famous case study from GM in 2014. They had to issue a recall for this simple little part, which is a part of the ignition switch. So just based on the difference in this spring constant, which is a function of that length, this was not a sufficient amount of force, which basically allowed the ignition to turn off while the car was operating. It ultimately resulted in 13 people dying, and GM had to issue a recall, which ultimately cost them $1.3 billion. And a big part of the reason why that was such a huge deal was because this part was not adequately tracked in their system, so they could not identify exactly what cars were owned by who that were at risk of this potential failure. So they had to recall a far larger number of cars than was necessary. Design quality versus production quality. This is a really subtle nuance, which I think is very important. And it's also useful because in the medical device world, in the FDA regulation side of things, the terminology is the same. They talk about design quality and design master record, design history files, and then they talk about device quality, device record, master record, and things like that. The subtle difference between these two D words is the design doesn't physically exist. The design is your CAD model, all of these documents that we've been talking about, all of the specifications on how it performs, how you'll know that it will perform to meet your customer expectations, simulations, anything like that, that it basically tells you that if this is made according to these documents, it will perform in a certain way. The production or the device side of things is all of the physical world aspects of, we can intake this information like a printer or a 3D printer. We can take these digital files and we can produce a physical product time and time again, which will perform in the way that the design is anticipated to produce. And so quality is broken down into also two different sort of management sides of that. How are you managing and validating, verifying your design? How are you validating and verifying, managing your production quality? There's also sort of two aspects to what you're trying to manage there: reliability versus durability. So reliability is, will it work the same way throughout the whole product's lifespan, or across different production batches? Durability is, can it withstand acute stressors in the environment? So when I worked in the nuclear industry, we had sort of thermal and mechanical analyses for operational, like regular operational use, like regular thermal cycling of the plant warming up and cooling down. But then we also had specific acute analyses that we had to do to make sure that things stayed safe over time, like a certain number of earthquakes would hit of a certain magnitude. A certain number of pipe breaks would cause water hammer to cycle through the whole piping system and cause acute mechanical loads. All sorts of different, like really a lot of different things. I don't want to do an actual breakout session right now. I'd rather sort of save that for the Q&A portion of the discussion. But this is a good activity to do for yourself. It's sort of a simplified version of the quality plan, which we'd recommend you fill out. And the book has an example in there for a refrigerator, basically. And it breaks it down into these 4 generic categories to think about whenever you're talking about your design quality: the industrial design, aka the aesthetics and your user interface, the sort of first impression of your product. the features of how does it function, or what features are a part of your product. And then the performance side is how do those features perform, durability and reliability. So in the example of a refrigerator, we would say we want this to be a stainless steel refrigerator. So that's part of the aesthetics. The freezer's on the bottom, not on the side. We want it to be perceived as ergonomic. Features, multiple drawers, an ice maker, humidity control, water purifier, and a monitoring app. These are just energy usage, inside volume, noise level. None of these things, back to the first session's presentation, none of these things are defined yet. They're just generic items to consider. And so the next step of that would be to put a specification on it where it's, okay, inside volume, noise level, we want it to be quiet, but below what specific level? So you'll see this very similar to the PRD at this point, but just putting it into these specific categories, or rather it would actually live on your PRD. So that was on the design side. You can apply the same 4 sort of generic categories to the production side. So once you actually start producing these, is the surface free of defects? So we want it to be stainless steel. Say it's brushed stainless steel. Is that brushing homogeneous, or is it free from any unique scratch or visible scratches that go against the brushing, stuff like that? But this is just all tied to the actual production units and how you would test and measure whether or not unit 1, 2, 10, 10,000 sort of still meet the customer and design expectations. So on the quality plan side of things, there's another subtle vernacular difference here in quality management, which is validation refers to design. Did you design the right product? If you come up with this file print set of documents and instructions which would allow you to produce a physical product, how do you know that that set of instructions will actually meet your customer's expectations? That's validation. Did you set the correct specifications? Verification is now you've built the product, you've built a physical thing. Did you actually build it right? Did you follow the instructions? And so those are 2 different quality issues, which depending on if you're managing and making everything in-house or if you're utilizing contractors, they can be very different issues that you need to tackle in very different ways. So it helps sort of have all of that stuff laid out. Restart laid out. So the quality test plan is ultimately what captures all of this. How do you verify and validate that your product meets the specs, so your PRD? How do you verify and validate that the system performs as it's intended? And what are the quality tests that need to be run in order to ensure that stuff? And then where does it get documented? So documentation is essential for regulation. You can get away with not actually maintaining a historical record, especially if you're in an unregulated industry or if your liability is extremely low, but it's not best practice. And the bigger you get, the more liability you'll be exposed to. So something to consider setting yourself up for from the earliest stages. We recommend that you would start finalizing this quality test plan before you start your EVT testing. And so EVT, engineering validation testing, is when you have assembled all of your systems into a looks like, works like prototype. So this is before you've begun to sort of optimize anything for scale. You can still be making this. It can still be 3D printed parts. It doesn't have to be producible at scale yet. It's just fundamentally testing and verifying your engineering and your design specs. That's when you'll have enough information to really go on to know that you can lay out a full quality plan for the production side of things. There might be a lot of TBDs depending on what ultimate method of manufacture you settle on, but that's going to continuously evolve. You should at least have a placeholder by that point. So what's in the quality test plan should be a list of the tests, as well as a high-level description and a link to a more detailed test protocol, which we'll dub an SOP, a standard operating procedure for how to conduct that test. You'll want to rank these particular quality issues or tests that you're doing in terms of criticality. If it's critical, it's safety related, zero tolerance for that typically, or a very low tolerance, versus a cosmetic defect, which sort of just maybe erodes your customer loyalty or your reputation in the community, but isn't ultimately going to even affect necessarily your business performance in a direct way. It's also good practice to put the timing and how long a test will take on there, as well as what type of sample do you need for this. Can you start with an EBT prototype, or do you need a production unit in order to adequately test the quality spec that you're putting there? And then also sample sharing. Can this sample be used for other types of tests? Because it can be, especially in the regulatory environment or getting any certifications, it can be expensive to get a statistically significant number of units to a testing lab to test them for an extended period of time. What happens with all of those units once you've, tested them? Can you give them to a customer? Can you use them for like an interference test of some other kind, or a destructive test? Let's see what else. Yeah, and basically it should correlate to every specification that you have on your PRD. And here's a more extensive list. So that the breakout section had sort of 4 broad categories, but here's a more extensive list of things that you might want to consider including in your quality test plan: specifications, functionality, aesthetics, durability, reliability, accelerated stress test. This is testing a unit to failure, or an accelerated life test, which is to more scientifically determine what your actual product lifetime is, if you anticipate this unit being something that will be used to failure, and then the failure of it at the end of its life might be a sort of safety critical objective. User testing, packaging, shipping, storage, and then ultimately certifications, legal requirements, things like that. So here's an example of what a filled out prototype test plan might look like. You'll see it follows a similar format to the bill of materials, where it has a label down the side, a category for, sort of based on the previous slide, what category does this fall into, a specification that you're trying to meet, and this could be an industry standard specification or an internally generated one. A description of what's happening in that test, a brief one. What phase of your product needs to be tested in this, and that's probably a minimum, where you can always test something at a later stage, but it might be, this will really allow you to sort of rank those tests as to when you should start running them based on your development cycle. Criticality, major, minor, critical. Sample size, how many units need to be tested. And this is, a sample size of 2 is deemed adequate here, but 100% for this one. Every unit needs to be tested. This is an example of that sample sharing. So when you drop it from 30 inches onto a wood floor, this can also be used for chemical durability tests. So if you're going to expose it to sort of salt water or acid fumes or something like that because of your operating environment, if the shell is cracked, it's probably not going to tell you, or it's not going to interfere with this test. So then you can get some efficiencies there. And then, as I'm a huge fan of always linking to the more detailed document, which sort of outlines what is the specification and or how do you perform the test that's described to meet that specification. SOPs, a little bit more detail on what should be included in them. think about what equipment you need, what's the testing procedure, and then what is the evaluation criteria? How do you know if the test is passed or failed? Also, you should include probably where does this information get documented? And if you're using your manufacturer's quality team, they may have a standard set of SOPs that they already use. So you don't necessarily want to go through the process of developing one specifically for them when it doesn't fit in their system. So it's a good question to ask before you even sign your sort of PO with them. And let's see, yeah, many SOPs can be reused for subsequent product launches. So something to consider as well. Also, all of the standards, there are standards out there for different types of products and industries. So you can almost definitely look up what the product requirements are for a phone. How many drops from what height onto what surface are they designed to withstand without a case? Or then there's almost certainly specs for cases to protect a phone. So developing the overall timeline for this, you want to develop your first quality plan once you have your PRD outlined and while you're still finalizing your EVT. And then for every test, you'll want to generate an SOP. That could also be asking your manufacturer if they have an SOP for it. What's up, Adam?
I'm wondering, before we proceed too far past these kind of quality standards, if we're making a consumer product and we're setting we're setting our own quality standards in a lot of cases, I think. Can you talk for a second about like what is in the realm of reasonable? You know, when working with the manufacturer, you know, one of the things I'm concerned about is coming in with essentially an unreasonable set of expectations for quality, you know, defects out of 1,000, et cetera, that increases the cost of my initial quote, right? Or basically gives me a false sense of how expensive the manufacturing process is because those quality standards are set too high.
That is a great question, a great point. So I need to add that as a note, because everything that we're talking about here does not necessarily, I would not necessarily recommend sharing it with an outside contract manufacturer. This is more sort of for your own documentation internally. And back to the sort of medical world, again, that is a great example because that is sort of the gold standard for quality management. You'll see certain manufacturers have ISO 13485 prominently listed on their website, which means that they are certified to maintain a quality management system that is acceptable to the FDA. So the FDA wouldn't come to your shop to make sure and check on the quality documents and the quality program. They would go to your manufacturer, and your manufacturer is charging you for that. So that's why it's super expensive to make medical devices. Anything for the nuclear, the aerospace, the defense industry, they're all highly regulated industries that follow these sort of standards. If you're more in that consumer market and you're trying to compete on price, it is going to sort of be a judgment call as to how far on both sides of that spectrum do you want to go. And I will say manufacturing in China is the farthest side on the opposite side of medical devices. You can make medical devices in China, but also you can just send somebody an image and say, can you make this? And they'll make you something. No specifications, no testing, no nothing, but they'll make you something. It's going to be up to you to sort of set that balance. And I think one particular like tactical way of trying to set that balance is to start with only the information which you think will excite them to want to work on the product, and then start by requesting samples or issuing an order for a very small number, always under the umbrella of saying like maintaining the excitement of how much potential there is in this business. You know, you're going to order, you're anticipating 2,000 to 5,000 units per year, but you know, we want to validate your procedure here. Can we place an order for like 5 so that I can check your quality on it? And then that can also be a good way for you to not necessarily go overboard even on the documentation side of things, because if you don't intend on switching suppliers and they can produce the same thing every time, you can document that quality after the fact. Once you realize, okay, you're making it this way, as long as you use that machine to make this part, then it will come out with acceptable quality without me needing to check every little thing. But that kind of comes from touring the factory, understanding exactly how they're going to make it, understanding what causes those process variations and problems that you then need to add quality steps for. And that's super common practice, is to start with smaller. It's even written into the MRL that when you get to that PVT stage, your production validation test prototype is actually probably the same as your later stage products and tests. It's really just ordering a smaller quantity so that you can validate the production parameters, not necessarily any additional changes to the tooling or design. Does that make sense?
Yeah, that's I think some examples for me about, you know, how to approach a manufacturer, or what language even to use. And you and I can talk about this off the call, but you know, not coming from a background in manufacturing, but or even in design, you know, I don't want to look like a fool right off the bat, you know what I mean? And so kind of learning what is, and I guess what I'm asking about is industry standard in general for, you know, manufacturing practices and stuff. So yeah, anything we can learn about, you know, here's what you're expected to ask for, or here's, you know, asking for 100% quality on every metric for 1 million units is unreasonable. But like, where is that reasonable line? And how much does that vary by manufacturer? And how do you approach a manufacturer about their quality without kind of putting yourself in the category of a potentially pain in the ass client?
Yes.
So that's kind of what I'm getting at.
Yeah, that is something that I think we can dig in deeper, like individually on, because it does sort of vary depending on who you are, what industry you're in, what method of manufacturing, what size of manufacturer you're trying to work with. But yeah, we can. It's a balance that you'll need to strike. But I wouldn't worry about looking like a fool. It really does apply that there's no, the only stupid question is the one that goes unasked. I've seen people with absolutely no experience walk into a manufacturer and they just get totally endeared with the project and the attitude of the entrepreneur and want to work with them even though they know nothing. That's why many manufacturers get into it, is because they like making stuff, so they don't want to be micromanaged. But we can talk more about that. I don't know, did Mara or Stephanie have something to add on the topic? If not,
Yeah.
I'll go into questions.
I just wanted to jump in, and not to totally derail on this, but a place to start to get some familiarity, just like to get some working expertise, so you don't feel that kind of level of you know, I don't know what I'm talking about, is looking up AQL limits, so acceptable quality limits. And there's a lot of generally accepted industry standards around those limits. And once you kind of figure out your AQL limits, and then like what category of thing you're manufacturing, like I'm a type F, for example, in my medical device, and my AQL limits are 1%. Yours, there's lookup tables you can look this up. That sets for you what your sampling plans are. So if I have a lot size of 100, I have to sample 12 units out of that. I don't have to think about it. It's just kind of, that's what lookup table says. So if you can do some reviewing to figure out about what category or what AQL makes sense for your industry, and there's standards by industry, a lot of that stuff you can just walk in and say to a manufacturer, I'm looking for an AQL level around 5% and this, and they can run from there, and you can refine that up or down. But a lot of that homework's been done for you once you figure out what category you're in.
That's a great point. I was going to say that is actually covered in the 7th presentation in this series, where we dive into more of the AQL.
Sorry to jump ahead.
No, it's okay. I forgot to mention that midstream, so thank you for bringing it up.
Yes, thank you.
Stephanie?
Yeah, I would just add from just a practical standpoint, especially if you're at the quoting phase, what I've been doing is just getting quotes from everybody. They're supplying the quotes, and as you dig into the details of the quotes, for me, it's been beneficial to first get some numbers around it, and then go back to them and say, okay, what kind of quality system do you have for, with this type of level of development that we're going to be doing? And if they are starry-eyed or hesitate or don't even know what you're asking in terms of a quality system, then that's going to tell you right there they've got nothing in place, and or that they're pretty loosey-goosey, which can happen with consumer goods in particular. And if they come back with questions like, well, what do you want, and they're going to put the onus on you to see what you can be very vague and just say, hey, well, obviously at lower volumes, we're going to need to do 100% testing to make sure that we're ironing out the kinks and there's no major problems. And then at some point we'll veer off into sample testing. And what I'm looking for from you is, at what level do you guys normally start veering off into sample testing? And then I'll go back and figure out if that's going to meet our quality requirements on our end. And so you can enter into the conversation pretty vague and get a lot of information and figure out what that sweet spot is for you.
It's a great point. Thank you, Stephanie.
Yes, thank you. That's very helpful.
Awesome. Back to our regularly scheduled programming. So yeah, after you do the test, you'll want to run the test and report the results. And then one last step, which we don't really cover in the templates, is to create a summary of those results and documentations. And then also, how does that sort of feed into your failure modes and effects analysis? Because if you start to identify a recurring quality issue, you sort of need a way to create a change order to address that issue if it reaches an unacceptable limit moving forward and your manufacturer just can't meet your quality requirements. Let's see. So the second session, or the second breakout session, which we can sort of walk through at the Q&A side of things, is to determine a quality test which you could put on your product quality definition in order to assess whether or not it's actually meeting, and then what is the criteria to determine whether it's passed or failed. And this is where Mara's point of the AQL can come in, where on the actual test plan you can set sort of what are your sampling limits to meet a specific AQL. And if we have time, I'll bring it up just to show you sort of one of those tables. And this is again broken out between two, on the design side of things, and then again on the production side of things. Yeah, we'll go over that at the end. So process capability, this is one of those things, and sort of to your point, Adam, where it's like, if you don't necessarily fully understand the process, it can be difficult to understand what reasonable variation is and whether you're asking too much of the method of manufacture or not. And unfortunately, that the way that you get to that is by experience and touring and asking questions. And there's so many different ways to make something, and you're never going to know until you actually go through it. If you have the budget, you can consult an expert, or the better way is to get a manufacturer to want to work with you, and then asking them, because they're going to sort of be resident experts on the technology that they have. So definitions of product variation versus deviation. I'm going to skip this slide because I think it's adequately assessed in the example that we're going to go through. But engineering drawings and tolerances, this is the whole objective of creating engineering drawings like this with tolerances, is to account for process variation. And so you need to sort of understand what is reasonable process variation for the method of manufacture that you're selecting for that part in order to set those tolerances. One example is my ice mold is compression molded with silicone. And I don't know what a normal process variation is for this particular compression mold. And also it's going to vary based on footprint. So I had to ask them, you know, on a product with this amount of footprint, what is a typical process variation? And they said, okay, over that length and with this mass of material, it's going to be 0.3 to 0.5 millimeters in shrinkage. So I had to adjust my design so that it would still fit into my water vessel, because if it was above the certain limit, it wouldn't fit. And if it was below the certain limit, it would float because it wouldn't have enough friction by wedging into the water vessel to hold it down. And so then it also became a function of my draft angles to know exactly where my design limits were so that it wouldn't, one unit might not fit and then the other unit would be too loose. When it's within normal process variation and there's nothing they can do about it. So yeah, unfortunately, some of that stuff is just going to happen while you're doing your production validation testing, and you're going to need to uncover it and address it. So simple variation, or simple idea and way to understand process variation is in statistics with standard deviation. It's to do this exercise, and I would love to actually do this one day with people. You just give people the general instructions, say cut 103-inch strips of paper. Don't say anything else. And then you take a pair of calipers and you measure exactly what the length is of each strip of paper. What you'll end up with is a distribution of sizes where, you know, it's going to be 3 inches or 3.001 inches, 3.005 inches, 3.1 inches, 2.95 inches. And it will look like a bell curve. And so your standard deviation is what is the size that gets you within plus or minus 32% or whatever from the middle of that bell curve. Now, every single manufacturing method is going to have a tighter or a flatter distribution around a certain sort of length scale. Now, if we take this example and say, cut 3 inches using these scissors, that's going to be different than if it's cut 3 inches using like an X-Acto knife, cut 3 inches using a jig or like a paper cutter. All of those things are going to be modifiers to the process, which would allow you to either maintain a tighter or a more loose distribution around a given size. And so that is, to me, like a great example of understanding what the process is, understanding all of the different little sets of instructions and helpers that can be placed in order to hit different levels of different standard deviations around that bell curve. And another thing to consider too is how many people are involved in your manufacturing process, because each individual's distribution is going to look very different than if we all did it. If we all do it, we're adding in many additional variables. If one person does use an X-Acto knife, one person does use a ruler or a jig, one person actually measures it and cuts on a line. All of those things are going to be variables which will cause a flatter distribution. And the same thing will happen if you end up trying to do multiple suppliers for any given part, because everybody's going to make things a little bit differently, a little different number of people involved in the process. This is the essence really of MRL and production quality, is understanding just all of the factors that go into that and which ones do you actually want to monitor and control for versus what design parameters can you change to not have to worry about it. Another thing to consider is rework. So your lower acceptable limit and your upper acceptable limit. If something is over your upper acceptable limit, you might be able to actually modify those after the fact and cut them down to increase the number of acceptable units that you have. But if there is a actual hard critical lower limit, then anything under that, like my product won't fit in the water vessel anymore, then you just have to scrap that part because it becomes useless. And so this will go back in and factor into your sort of your BOM cost and what your acceptable costs are. To Stephanie's point about there's also the ability to go in the opposite direction. And this was something that I found very funny about my manufacturer in China, where they'll say they do the quality testing and management in-house. They don't really have the actual experience to implement the program as it was designed. So they'll say they meet AQL and like this particular mil spec, but then they just give me 100% qualified units. Because when I order 100 units, they don't make 100 units, they make 120. And then they just throw out all of the rejects and deliver me the 100 that passed. But they'll still generate a quality report that says how many defects they found. And that's going to be one of those things that every supplier is going to be different. If you walk into one and they're willy-nilly and they don't know how to implement it, it could be an opportunity or it could be a risk. And that is going to come down to your own sort of assessment. But the real critical thing is only you can identify what your key characteristics and your limits are. And then also you are going to be the one that has to set what your acceptable defect rates and limitations are. Now, like Mara said, there are a lot of standards out there which have become industry standards, and you can look those up and try to conform to them. But especially in unregulated environments like a consumer environment, you don't have to, and many people won't. So it really comes down to your quality philosophy, your ethics, your mission, and what you want to be known for at that level, provided that you're not killing anybody. We showed this in an earlier presentation, but this is a great example now that you have a little bit more of that context with the sort of standard deviation bell curve. So this is essentially a representation of the bell curve for length tolerances with different types of cutting processes, basically. So flame cutting will give you right around this sort of 50 thou. It can get down this precise, but you're going to basically pay more. And at that point, you might want to just consider hand cutting and grinding because it's in the sweet spot of that particular method as opposed to being the upper limit of this one. This is where it takes a pretty intricate knowledge of all of these different manufacturing methods so that, you know, somebody generally who does flame cutting doesn't also do electrical discharge machining. Maybe not. And if you ask the person who only does flame cutting if it can be done any better, they're going to say no, it can't. But they just might be ignorant of 7 different other ways to do it. And that's one way that asking your peers, relying on my office hours, looking for competitive or analogous products and people that do it, just getting more experience with how things are made and is the best way to sort of understand that. So we mentioned this before that everybody who would be eligible for the next core grant funding needs to complete the full DoD MRL assessment. You did this initial assessment. Most people did this initial assessment before the program started, which gives you sort of a rough idea of where you are at your MRL level. But the full DoD MRL matrix actually contains a lot more than that. It has 9 traditional manufacturing risk levels, which are denoted by A through I. And then it has 22 sub-threads. So some of them have 2, some of them have 3 different sort of sub-threads, 3 or 4 different sub-threads with each manufacturing risk level or risk area. The way that you complete the template, which is in this week's folder, is for each sub-thread, there is basically one checkbox, which you will go through and read them and see which one applies to the current physical product, this current state of the physical product that you have. In this, there's a lot of pitfalls and random things that we'll talk about in general, but the general rule of thumb is the MRL is all about manufacturing. It's not necessarily about what you hope and plan to do, but what actually exists in reality. So if you have something designed and you know that it theoretically will work, you can't really say that you have a works like prototype until you have actually made one and prove that it works. So what happens is when you complete the checkbox for each one of these threads, it will sort of assign what your sub-thread MRL level is, and it gives you a more three-dimensional view of sort of where your product is currently weakest or most at risk with regard to production risks. And yes, this graph does not match this one because I just threw that in there. But in general, this is the number that you saw on that initial set assessment, just the one number, which is dictated by whatever the lowest subthread is. So you might be able to rapidly boost that number just by tackling a few specific risk areas that the MRL identifies. Yeah, we can dig more into this if it's of particular interest to you. But there's a lot of information in here about some specific pitfalls and things to not worry about. Yeah, this is the one I was talking about, potential future work. Don't assess based on what you plan to do, assess based on what has actually been done. Don't assess based on models or simulations, assess based on prototypes. Also, at certain levels of it, it's not based on what you've done for a single prototype, but what you can repeatedly produce. It's not based on what your company is capable of doing. If you've made products in the past, it doesn't matter. It's what do you have in place for this particular product. Can't be based on undocumented information. Sort of MRL level 1, 2 is your PRD. So if you still haven't filled out your PRD, you can't be at an MRL 7. Like technically my product's not at an MRL 8 or 9, even though I'm selling it to my customers because I still haven't finished my PRD, which I'll do before the end of this year. Hold me to that. Yeah. Also, one thing that is particularly challenging about the MRL is that it's not super useful for lean startup and iterative design methodology. It doesn't inherently capture the need to sort of test specific assumptions, break down specific components and bring them back earlier into the cycle to develop them again and move forward again. And that's sort of this last pitfall is you don't want to necessarily assume that just because you made a new prototype, it's advancing you from an engineering prototype to an engineering validation test prototype. It could actually take you backwards because you find out that you need to make a design change. It's not a linear process. That's probably the biggest one. It drives me nuts every time we hear a pitch and somebody says, yeah, this is our cost right now and this is what our cost will be at scale. Because I just know that 9 times out of 10, they're basing that on an assumption that is completely undocumented. And the costs don't always come down as dramatically as you anticipate at scale, especially for various different components. And there can be a large range of readiness levels depending on your subthread. So the one example that we saw there was pretty homogeneous with a couple that were at 3, but the most advanced one might be at 5. You can be at like 7 or 8 across the board, and then just one particular thing is holding you back at 2. It does not mean that you can't have a product and that it's not a good one, that it doesn't meet a customer need. It just means that you're potentially over leveraged and have a risk that might come to bite you in the butt. So if you did receive one of the grants and we need to get you set up to talk to our IT, basically you'll come out once you fill out that spreadsheet. There are different lines for your assessment versus our IT's assessment. And so it's very normal that your assessment will vary dramatically from what our IT thinks you are at. But basically it's just a 2-hour conversation with them where they sort of ask about each specific aspect of the design or your prototypes and your subthreads. And then they come up with their sort of recommendations on what they think you should focus on from a manufacturing risk level perspective. Ultimately, that is one of the critical things. You'll get out of it what you put in. So be honest with yourself and the status of what it is, and be honest with them. Also acknowledge that you are the technology expert. They are not going to know your technology, your solution, your problem, your customer's pain point, your market nearly as well as you are. But also be open to the fact that maybe you don't know it as well as you think you do. So ultimately, they, like I said before, they are looking to assess your actual volume and what your capabilities are to scale and increase your volume. And it's based on what you've built and how much of the design is actually solidified versus still changing. So I definitely recommend filling it out. Feel free to throw some time on my calendar to review it or ask me any questions. One thing that threw me off is I learn something new every time I go through it with them. Some of these subthreads don't have anything in them. And that means that if none of these apply and there's nothing lower, then you're probably just at this MRL level, because at this MRL level, you shouldn't even have to be worrying about a producibility program, because you don't even really have a prototype yet at MRL 2. So don't feel the need to put in something higher just to fix or just to have it. It generally means that you probably don't need to worry about that manufacturing risk level, because you're not actually manufacturing at that level yet. All right, homework. We talked about that before. Take a stab at filling out the prototype quality test plan. Any questions? If not, we can go through some of the documents and I can pull up the AQL level from the 7th presentation. Remember, you can always throw some time on my calendar to go over things one-on-one and dig in more specifically. So yeah, that presentation is a doozy. It's a big topic with a lot of potential variation depending on what specifically you're working on and what you're doing. All right. If nobody has any questions on the top of their head, I can pull up the so in this week's folder, you'll see there's the MRL template, and then this prototype quality test plan template. The full one is set out to be a lot of these fields sort of map to PRD fields, and you can add or subtract from them as needed. So operating environment, you see like temperature ranges and humidity. Same thing with storage, separate temperature ranges and humidity. Regulatory environment, I really should move this to the bottom because at this stage, it's not necessarily going to be your number one consideration. It's probably more like design, your electrical, mechanical specs, durability, packaging. Something that oftentimes people neglect, serviceability. So this gets back to what is your product lifetime? Do you anticipate servicing them in the field? Do you anticipate receiving them back and refurbishing them and sending them out? Or will you just send a replacement? Will you scrap it? Will you send a new one before you even receive the old one back? Or is it big enough that you actually have to go on site to perform service? And what does that look like? I put a note here on the criticality one, which actually alludes to the AQL. So general definition is there are critical defects, which are safety related issues, something that could harm somebody. And a general AQL level for that is, you know, a 0 or a low percentage tolerance. A major defect is something that would likely result in a return or repair request, service request from a customer. And the AQL level that typically corresponds to a major defect is 2.5%. The minor defect is a sort of cosmetic issue. This is something that you get this product, you're going to be maybe a little disappointed. Some customers will notice, some customers won't, but the ones that do, it's going to sort of erode your reputation, your customer satisfaction. It's not going to allow you to have that sort of pristine Apple reputation. In an AQL level, a common standard AQL level would be like 4% for minor defect. Now, that's how you can sort of start to spec your quality mission as a company. Is if you want to be Apple, maybe 4% is too high. As Mara was saying, you can sort of increment around those different levels. See if I can just pull up. I don't know if that's big enough for people to see. Okay, so AQL levels. This is the 4 that I was talking about for sort of a minor defect, which means that sample size code, in order to achieve a 4, you need to test at least 3 units, and you cannot have any defects to hit this 4% AQL level. However, if you test 13 units and you have only 1 defect found, that means that you've hit this level at 4. If you're able to test 200 units, that means you can find 14 and hit an AQL level of 4. But if you find 9, you actually hit an AQL level of 2.5 for that minor defect. And so these numbers of sort of what is your sample code is basically what you would dictate to your manufacturer of how many do you want to test. And then your choice is the AQL. What AQL level do you want to hit for what level of criticality of defect? It's a super brief overview, but that's sort of what Mara was talking about is general inspection levels, special inspection levels. There's industry standards that sort of equate to what you're trying to hit. In a regulated environment, it's more like enforced. You have to hit this or else you lose your certification. And then there's also, so there's the template in here, which is just blank. There's an example, which is filled out and basically in that document, but it doesn't actually link to any real SOPs. So it's not particularly valuable. And then the breakout exercise is also in here. where you can sort of see on the design side, your design quality specification would be, you know, stainless steel, freezer on the bottom, ergonomic. How would you test that? List your sort of tests, 1, 2, 3, and then specify your pass-fail criteria. That's all I got for today. Does anybody have any questions? All right. If not, I'll return these extra 15, 13 minutes to you guys. Thank you for coming and for the questions. As always, I love the discussion.
Thanks, Matt. I'm sure I'll have some more questions as we as I dig into some of the AQL stuff.
Yeah, feel free. See you, Dylan.